Okay, I went ahead and added in the rest of the bases till we're now right up here at this replication fork. So we had split it open, DNA polymerase has added in its bases, and now we're right here at this part of the replication fork where helicase would have to come in and break more of the bonds. And so we've formed this basic bubble, and in your textbook and in the notes from the class you'll get a picture of more what that bubble would look like. But here I'm more concerned about you understanding how this thing works. This side can continue to add as long as the helicase continues to open up, unzip the piece of DNA, and there is a complement, there is a nucleotide on the other side for it to add to. Alright, now let's switch over to the other side, and I want to show you kind of what's happening on this other side here real quick. So let me disconnect all of that stuff. And I'm going to flip it over here to this other side, the other leg of this DNA strand. So here we go. Just to move up a little bit. So here's the other side. Now remember, it had split, and now we have this other side here that needs to be added to. So here's our adenine, and with adenine we add in thymine. And so if we add in this thymine, again, we got our 5' end here, this thymine, we've got our 5' end here and our 3' end here. Please remember that DNA polymerase only adds to that 3' end, and so we have a small problem. The DNA polymerase needs to add in this direction, needs to add to that 3' end, but there is no base here for it to add to. And so what has to happen is when the DNA is split, when it's unzipped by helicase, this side has to wait until this side has made a sufficient amount of copying so that we can then put in our special primers that we have to get the process started. Again, pre-AP, you don't have to understand all the primers and things like that, but in AP and IB they will. They'll teach you that there. And so we're going to move up on the sequence to a point where we can then start copying and work our way back the other direction. So let's find that point. And I think I'm going to go ahead and start with this cytosine. So we don't need this thymine yet, but what we do need is a guanine. So our primer was added, our little thing that says, hey, DNA polymerase, start adding here. We're going to add that guanine right in. Move this thing out of the way a little more. We're going to add that guanine right in. So I need to get a piece of tape. We add our guanine in right here. And now we have our 5' end and we have a 3' end. DNA polymerase can add to the 3' end. It's got a base it can add to. It's got a direction it can go. It's got a place it can go, so it's going to continue to go that direction. So let's continue to add those bases in. And again, remember, it's got to go from attached to the 3' end here. So it's got to go, in this case now, away from that origins of replication, where from that spot where helicase stopped cutting, it's got to add in the opposite direction. And don't forget that not only are you creating this hydrogen bond, but we are also creating this bond between the phosphate and the sugar, the 3 carbon on that number sugar, that number 3 carbon here. So let's add another one in. And don't forget, again, that phosphate always added to that 3 carbon molecule. And remember, again, DNA polymerase has to add to the 3' end. So I'm going to go ahead and add the rest of them here.